Okay.
Okay, so loudness.
All right.
Loudness is the amplitude of the wavelengths.
Yes.
And so, would you be able to define amplitude?
Amplitude?
For me, yeah.
The height of a wavelength.
Okay, so
Yeah. Is it high? Or is it small? So if it's small and close, this means the pitch is high. If it's long and
so it's
far,
gonna be quieter to us.
yeah.
Okay, so the bigger the amplitude is, the louder it's going to be, which means the lower of
So
the
the
pitch.
bigger the amplitude is, the more the pitch is.
The more the pitch is.
Yeah. So the more, if the pitch is more, then it's gonna be
It's
louder.
going to be like a higher, it's going to be,
Yeah.
we'll hear it louder, but it's going to be a higher pitch
Yeah.
type of a noise.
Yeah. So you're like, if it's long, then it will be like way far.
Yeah.
If it's far, then this is like this is not loud. This is like low sound. Right. But if it's small, this is gonna be like together.
Okay.
This is what loud is. So if we whisper, this is the whispering wave.
Okay.
If we are shouting, this is what shouting is.
Okay.
Does that make sense?
Yeah, so it's the shorter
The shorter
waves,
and the closer.
the shorter and closer, the louder it is.
Yeah.
Got it. Okay.
Because you're like, if you increase the energy, your wavelength is like frequency increases and your wavelength will be more closer. So when we speak loud, our energy is more increased.
Okay.
Like we like stimulate more energy.
Okay.
Right.
That makes more
What was
sense.
that?
then. My answer is frequency, and timbre. Timbre is just if there's like another noise, like another frequency mixed in with it, right?
Timbre, yeah.
Okay.
Yep.
Okay.
It's more frequencies. So you know the three parts of ear?
Of the ear, no.
Alright. Stimulate.
Is it?
Alright. So your ear is. So this part is called outer ear.
Okay.
This part is called pinna, and this is ear canal.
Okay, ear canal, what was that one?
Pinna.
Pinna?
Yeah.
Okay.
This part just what it do is gather all the vibrations.
Okay.
Alright? And the function of this is to lead vibrations to go through ear canal. Alright.
Okay.
So and this is what we call conduction.
The whole thing's the outer ear.
This whole thing is outer ear.
Okay.
And then this thing, like this is pinna and this is ear canal. Its function is to carry all the vibrations and direct it towards the ear canal.
Okay.
Right? And when the vibrations are going from the ear canal to the stuff like to the inner ear, this is called conduction.
Yeah.
So we have like 3 bones. You can just draw them like this. And then this is oval window and this is. Alright. So this is the middle ear.
Okay.
Alright. This middle ear, it starts from the tympanic membrane, which is right here. Tympanic membrane is just a membrane, or you can call that eardrum, which is sensitive to vibrations.
So tympanic membrane is the eardrum.
Yeah.
Okay.
Both things are same. So it is sensitive to the vibrations. It carries the vibrations and hit this ear. These 3 bones are called ossicles, ear ossicles. Alright. This is hammer. This is hammer, anvil, and stapes. Alright. I don't know what names your book has.
Okay.
So there are 2 names: malleus incus and stapes, or hammer, incus, and stirrup. Yeah, here. It's hammer, anvil, and stirrup.
Hammer and little stirrup. Okay.
Yes. So this is hammer because it's hammer shape. This is in anvil, and the last one is incus.
Okay. What was that again?
Stirrup.
Okay.
Hammer, incus, and anvil, and stirrup.
Okay.
Hammer, anvil, and stirrup.
Okay.
Right. These 3 bones are combined, like in combination, they are called ear ossicles, and their function is just to carry these waves towards the oval window to cochlea.
Okay.
Alright. So they are just like this tympanic membrane is sensitive to vibrations. It takes it to ear ossicles, which ear ossicles vibrate like they hit each other to carry the waves towards the oval window. So this is the oval window of cochlea. What I do is it just provide a gate from where the vibrations can go in. Alright, this is cochlea and it's like a sensitive organ in the ear which actually interprets your information that you're getting from the vibrations there. And it has this part which carries the information towards the, so where the auditory center in the brain is?
Auditory center of the brain.
Yeah. This was occipital, this was frontal, this was parietal, and ear was right here. This is temporal.
Temporal.
Yes. So it's in the temporal lobe. So it brings all the information towards the temporal lobe where it is interpreted.
Okay.
In the cochlea, you have fluid that nourishes the cochlea, and also it provides the balance. Like it helps us to make our position like erect. If we don't have fluid in here, we won't be able to make our position erect.
Okay.
Alright. So when you spin a lot, this fluid is spinning. That's why if you stand even, you feel like spinning because the fluid is still spinning.
Okay.
Alright. In the cochlea, you have basal from oval window. There are some hairs. These hairs direct the waves toward the semicircular canals right here.
Those are the hair nerves.
Yeah, hair cells or nerves.
Hair cells.
Yeah.
Hair cell.
They carry the vibrations towards the semicircular canal where the vibrations slow down, and then it goes to the basal membrane, which carries the information towards the
Okay.
temporal lobe.
Okay. So the question I have is, we're supposed to learn about the frequency theory, about the rate of fire for the frequency. And I couldn't figure out, is the rate of fire for how the hair cells fire off the information, or the frequencies they pick up?
So frequency is when they pick up. So hair cells will move faster when the vibration is higher.
Okay, so the faster the rate of fire for the frequencies, the
Yes.
faster the rate of fire for the hair cells.
Yes.
Okay, that's the frequency theory.
Yeah.
Okay.
Does that all make sense?
Yes. And then there's volley theory, which is talking about the hair cells plus the rate of fire of each hair cell combined with multiple hair cells.
Mm-hmm.
So is that like the hair cells sharing the frequencies and bouncing back and forth?
Yes.
Okay.
So hair cells they are supposed to direct. That's why they are actually the one who decide how much frequency we need to send.
Okay.
And then in semicircular canals, I'm saying they slow down.
Okay.
So the hair cells direct the frequency towards semicircular canals. Semicircular canals are also deciding how much frequency we need to send.
Okay, so depending on the location of the sound and the rate of fire,
Yes.
the frequency decides how many hair cells will fire off.
Yeah.
Okay.
And semicircular canals.
Okay.
Because they are also, the vibrations slow down in the semicircular canals.
Okay.
If your vibration, like if we hear loud voices, our wavelengths are like really small and they're like full of energy, so they can damage our brain.
Gotcha. Okay. All right, so I understand the theories now. Thank you.
Mhm.
Auditory localization. Monaural. That's just saying, like, if I only have the use of one ear to really pick up sounds, I would have to rotate 360 degrees to pick it up. And the binomial is the use of both ears, and I just only have to rotate 180 degrees to pick up a sound.
Yes.
So, because I know you brought up time, like how's time come into play with it?
Yeah. So yeah, and this time will come like if you're hearing, because you're hearing with both ears here.
Okay.
All right. So it's like if you rotate just to 180 degree, then you are getting less vibrations. So the time and the amount of vibrations come in the specific time.
Okay.
Does that make sense?
Mm-hmm.
Cool.
Okay. Hearing loss. Let's see, hearing loss with old people. Is that just saying that they can't hear high frequencies with low intensity?
Yeah. And why? Because their cells are degenerating.
So high frequencies with low intensity.
Yeah.
So there's bigger but longer spaces in between.
Yeah.
Okay, so like, just like kind of higher pitched voices when people are talking a lot slower.
So what we discussed that the low the amplitude is, and the closer they are loud, and
Yes.
that's what they will hear.
Okay.
and if the amplitude is long and far, the lowest they will hear. Like they cannot hear the low pitch sounds.
Gotcha.
No, high pitch sounds.
The high pitch
Yeah.
sounds, okay. Gotcha, and then I don't understand cumulative hearing loss.
Cumulative hearing.
Cumulative hearing loss.
So I in this like ear canal I told about like there are these this is directing. So we have actually hair cells like here too that are directing the waves to go inside there.
Okay.
Alright. So this part has to just collect all the information, like all the vibrations, and then it directs here. The hair cells further direct that in.
Okay.
In cumulative, what happens is it's one of the conduction problem where these hair cells are damaged or they are no more there because the cells are damaged. The hair follicles no more grow the hair.
Okay.
So their vibrations are like roaming here and there. Some of the vibrations go in, some of them come back because they don't know where to go.
Okay. So you may or may not pick up some frequencies.
Yeah, they can hear a little bit. That's what they give response to. They were like, yes, what you said, because they hear something.
Oh, okay.
But they don't hear most of the thing because their vibrations are not being directed.
Gotcha, okay. And so there are hair cells in the inner ear and the canal.
Yeah. So here the hair cells will damage, here the hair cells will be damaged. So if some of the vibrations even go in, this hair cell is not directing them much.
Okay.